Hi everyone, this is Sudhir here. So today we are going to discuss related to Kubernetes setup and the configuration on different platforms. So different platforms like let's say on the cloud providers, on premises, okay, and how to use the existing Kubernetes services provided on different cloud providers. So let us jump quickly into the things which we are going to do. And before that, let us try to understand the architecture and the components which are present on the Kubernetes cluster. Okay, whether it is on premises or whether it is cloud. Okay, so we have to understand the components which are the responsibility of each and every component on the Kubernetes cluster. So to start with, we have two different nodes. Like it can be called as Kubernetes master or Kubernetes minion. Now you can call it as a, controller node, control plane, or the compute plane. So technically speaking, like you can call it with any name, but nowadays, like everybody started calling this master as a control plane and the worker nodes as a compute plane. So let us go with that particular technical term. Whatever it is, the ultimate goal will be the same. Okay, every node, it has its own responsibility, and whatever the technical name you call it, ultimately they do the same functionality. So though you call it as a different technical name, it doesn't mean that the behavior is a different. Okay, so let's put that particular point aside. So now let's divide this into two parts. One is like control plane and one is a compute plane. So coming to the point of control plane, so we have different components. Right now you can see a kube control manager, kube API server, kube scheduler, and etcd. On the compute compute plane node, you'll be seeing something like kubelet, kube proxy. So those are the two main components of your Kubernetes cluster. Apart from this, there are other few components which are responsible for a specific task. Okay, let's say on every node we need to have a Docker, any container runtime interface, not only Docker. So Docker or containerd or CRI-O. So these are the some of the container runtime interfaces which are supported for Kubernetes. So Docker is more popular, so that's the reason people used to use a backend solution for Kubernetes. For container runtime interface is Docker. So it doesn't mean that only Docker is supported. So we have many other container runtime interfaces which are supported for Kubernetes. So let's jump into that later. But those are the things which we have. Now, Docker need to be installed. Okay, any container runtime need to be installed on all the nodes. That is mandatory. Okay. Apart from that, what are the Kubernetes components? Okay. So on the control plane node, if you see, you have totally 4 components which are running on the control plane. So first of all, let us discuss about what is Kube API server. So Kube API server, the responsibility is nothing but whatever the request you send, whether it is from CLI or whether it is through API call, whatever it is, first will be received. The first component who will receive the request is nothing but API server. Okay. So the Kube API server will take the request, and based on the request you have passed, it will decide to whom it should contact. Okay. Generally, API server will contact to the etcd first, because it has to see what are the things available on your cluster, because all your cluster related information will be present in etcd. What is etcd? Etcd is not a database server. It's a key value pair storage. Key value pair storage. So your data will be, the metadata information will be stored on key value pair storage. Okay. Metadata information. So similar to etcd, we have so many other components like console, zookeeper. So these are the key value pair storages which we have in the current technology. Now among this, etcd is more popular and the preferred one for Kubernetes cluster. Okay, so you will be seeing this etcd in lot more other tools actually for OpenStack cloud providers. So you will be seeing this particular etcd key value store used. Now for Kubernetes also we are using this etcd. Now in this etcd, first your API server, when it checks the request, when it takes the request actually, first it will verify with etcd whether this particular resource is already existing or not. And then if it is not existing, it will try to update your etcd saying that I will be creating this. Okay, this has to be created. So once it is updated, your etcd will send an acknowledgement, and that will be received by your API server. And then Once the information has been received to the API server, then your entire cluster related information, which means that the state of the cluster will be handled by your control manager. So control manager will ensure that what is the state of the cluster, how many pods are running, what is the status of it, everything will be, this information will be collected by your control manager. That control manager will give the information to the API server, and API server will store the information in the etcd. Okay, so that's how it is. So none of the component is talking with each other directly. If you look at kube control manager and etcd, they are not talking each other directly. They are using API server as a mediator between the information which is getting passed from etcd to the control manager. Okay, so coming to the next component is nothing but kube scheduler. So kube scheduler is something where if you want to schedule an application, let's say I want to launch an application. So when you send a request, API server will pass the information to the etcd, and then it will see if it is existing or not. If it is not there, then it will talk to the a scheduler, and the scheduler will decide on which worker node or the compute plane we have to launch this particular application. The decision making will be done by your scheduler. How it will make a decision depends upon the resources availability and how many pods are running. Based on this particular calculations in the background, it will make a decision on which worker node or a compute plane it should launch the application. So coming to the point, like this particular communication is all happening between each other through API server. So as I told you before, API server is a mediator between these particular components, right? Once a decision has been made by your kube scheduler, then it will pass information to the API server. Then API server, to whomever it should contact, it will pass information to that particular compute plane. Okay, here if you look at the diagram, there are three control planes, sorry, compute planes. You can see 1, 2, 3 over there. And let's say it is scheduled on first compute plane. Okay, so when it is launched on the first compute plane, so then kubelet will receive the information. Okay, so once a kubelet has received the information, why? Because only a Kubernetes component can receive the information. Okay, so first it is not directly contacting to your Docker. It is talking to the kubelet, and kubelet will receive the information whatever it is sent by API server, and then it will pass the information to the backend container runtime interface. Whether it is a Docker, whether it is a container D, whether it is a CRI-O, whatever the runtime interface, it will pass the information. Okay, so that's a responsibility of kubelet, and kubelet will be running as a service like system D service. And your kube proxy responsibility is nothing but it is a proxy server who will bypass the information when you're trying to access your application directly using a port forwarding. When you're using a port forwarding or when you're using a service with node port and all, your kube proxy will come into picture. So then who will this responsibility of kube proxy is nothing but it will bypass the information from your user request to the application. Okay, so this responsibility will be taken care by your kube proxy component. So this is the overall picture of the architecture of your Kubernetes wherever you deploy. Okay, so these are the major components. Apart from this, if you are working on any cloud providers, of your Kubernetes, cloud control manager, there will be an additional component called cloud control manager. So cloud control manager is something where it will have different controllers like node controller, volume controller, route controller, service controller and all. So these controllers are only will come into picture only when you're working on cloud providers, Kubernetes with the cloud providers. Okay, if you look at the diagram on the top, I have written the cloud control manager components: node controller, volume controller, route controller, and service controller. Okay. So when you're working on on-premises Kubernetes cluster, so you see only a kube control manager. You don't see any cloud control manager. So that is the first point which we have to remember. It all depends upon the where you have installed your Kubernetes cluster. Okay. Apart from this, there are two more other components called as container network interface and then core DNS. If you look at this particular slide, here I have mentioned the control plane components and compute plane components over here. You can see kube API server, control manager, scheduler, cloud controller. Kubelet will be running on control manager as well. Okay, though it is not represented in the diagram, but kubelet will be running on both compute plane and control plane. Proxy also will be running on compute plane and control plane. Okay, etcd, API server, control manager, scheduler, cloud control manager will be running only on control plane. On the compute plane, you can see there is a container runtime interface. Okay, container runtime interface like Docker, container D, CRI-O, Fratec. Okay, so these are the components which are supported as a backend container runtime interface for Kubernetes. Apart from this, you have other components called CNI. Okay, container network interface. So in order to have a networking part in Kubernetes, there are separate plugins called as, either you can integrate Calico, WaveNet, Flannel. So these are the few major components of container runtime network which are used frequently. Calico is a more popular one because it has a BGP peering and network policy. We can create multiple IP pools. So that's the reason we use Calico. In production servers, we prefer to use Calico than any other networking part which we have. It all depends upon the organization. It doesn't mean that only Calico need to be used. It all depends upon the factors and the applications which you are trying to deploy. Okay, and the environment which you are using. It all depends upon that. But most preferred one is nothing but Calico. Flannel is only for testing purpose. Earlier we used to use only for testing purpose, not for production. Why? Because Flannel doesn't support network policy and other things. Okay, and nowadays it is deprecated after 1.17 version. This particular Flannel network has been deprecated. And then we have WaveNet, which is another container network interface which we have. Apart from this, we have co-DNS, which is an internal DNS service for Kubernetes. Why we need this is because Kubernetes will create a DNS fully qualified domain name for services and pods. Okay, when the pod is created, pod will have some fully qualified domain name, and when you create a service in Kubernetes, we'll have a fully qualified domain name. So these domain names are internal only for Kubernetes, internally within the Kubernetes cluster. You cannot access this FQDNs from outside. It is not a registered domain, right? So obviously you cannot access it. Okay, so these are the domains which can be identified by your Kubernetes cluster itself, not from the outside. You already know, if you want to purchase a domain, we have to register it. You need to add a proper DNS, a name servers, and there are a lot of other stuffs which are involved. But here, internally, for Kubernetes to communicate with FQDNs, like fully qualified domain names, it is providing its own DNS service to give that, so that it can understand by name or IP address. IP address, why we are not using? Because the IP address might change, but the FQDN doesn't change, even though if you recreate. So that's a strategy they are trying to implement with co-DNS. Okay. If you want more information, below you can see the link which is used for reference. Okay. So you can look into that. And coming to the next topic is nothing but what are the ways to install Kubernetes for on-premises and cloud. As you all know, on-premises setup, in the sense you will be creating your own VMs and you have to do the setup manually. Okay, so there is a manual setup without using any tool, that is called as Kubernetes hardware. That we are going to discuss. And we have minikube, which is like a standalone. Let's say some people might ask me, like, I don't have enough nodes to launch the Kubernetes cluster. Then no need to worry. We have a tool called minikube where you can launch one VM and you can install minikube and you can set up the Kubernetes. Okay, for testing purpose, for practice, you'll get all the features, whatever it is needed. But you're not using multiple nodes, you are using a single node for Kubernetes. That's it. That's the only difference we have. And then we have kubedium, which is a more popular tool to set up your Kubernetes cluster on premises. Okay, as a standalone and high availability both. And for Ubuntu, Ubuntu community has built their own tool for Ubuntu operating systems. If you try to install Ubuntu operating system 18.04 plus, means like 20.04 as well, inbuilt they are providing a tool called micro k8s, where you can install and you can set up Kubernetes cluster standalone. That is also standalone, where you can set up. Okay, that's the reason I have mentioned on-premises setup. Okay, that's the reason behind this, categorizing this as a on-premises setup. Okay, because we are not relying on any cloud providers, right? So that's the reason it is called as on premises. Okay, if you are relying on any cloud provider, It is called as cloud setup, right? Obviously. So coming to the next way of setting up the Kubernetes cluster is we have other tools called kops and kubespray. Kops is especially used to set up the Kubernetes cluster on AWS cloud, high availability and what do we say, a standalone setup as well. Okay. Kubespray is for all the cloud providers, including AWS, Azure, OpenStack, vSphere, Packet, Oracle Cloud, bare metal servers, even in the bare metal servers as well. Kubespray will be using Ansible playbooks in order to set up it. Okay. That's how it is designed. And we can also use a Terraform provisioning as well in order to set up Kubernetes cluster on AWS cloud. And apart from that, if you don't want to do it manually from your end, cloud providers are providing their own services for Kubernetes setup, which means that for me, it is not needed to spin up an instance and then install the Kubernetes cluster and all. It's not needed. Cloud providers are itself are providing the services, Cloud GKS, EKS, and EKS. Okay, Azure Kubernetes service, AWS Kubernetes, Elastic Kubernetes service, and GCP Kubernetes service. Okay, so these are the inbuilt services of cloud providers where you can directly use to set up the Kubernetes cluster. No need any knowledge, just you have to know how which version you have to use of which version you have to use to set up the Kubernetes cluster. That's it. Okay, but most probably it is not preferred, like it doesn't give you any knowledge. So as per my experience, I would suggest to learn on premises setup and then go to the cloud. See, once a person knows about the manual setup, it is for him it is will be easy to manage the cloud. That is what I believe. Okay, so because when you are using a cloud provider, you never know what is happening in the background. That's a small hint which I can give you a tip, like to learn any tool, whatever it is. First learn manually, then try to go with the cloud providers. Okay. So then you will come to know what is happening in the background, what kind of technologies they are using in order to set up these particular things. Okay. So next thing is nothing but what are the key points that we have to remember when you are setting up the Kubernetes cluster. There are a few points which we have to remember. The first and foremost thing is nothing but every node should have a unique IP address. Okay, that's a general thing which everybody knows. Okay, and the MAC address should be unique, and the product UID will be unique. Okay, these are the basic things which we have to verify. And all the nodes should have internet connectivity, because you need to download a lot of images in order to spin up the pods and all. Okay, in order to set up the applications and all, you need to have internet connectivity, which is by default. Okay, and other major thing is nothing but you have to disable the swap memory. Swap memory, if unfortunately a swap memory has been enabled, try to disable it permanently. Disable the swap memory. We'll see later. I'll show you how to disable the swap memory. And ensure that at least two vCPUs are needed, whether it is virtual CPUs or the physical CPUs. At least two core CPUs need to be there per node, not the entire cluster. For every node, you need to have two vCPUs on each and every node. That is mandatory. Okay, and as you know, we have to enable the firewall. If the firewall is there, if it is beyond the firewall, then you have to enable the you have to allow some few of the ports for your Kubernetes cluster to be up and running. Okay, those ports are shown in the slide. You can see the control plane nodes and the worker nodes, which are nothing but compute plane. Okay, so those are the 6443, 2375, and 2378, 10250, 10251, and 10252. Okay, if you see the purpose, 6443 is for Kubernetes API server. Okay, and etcd server and client API will be using 2379 and 2380. And 10250 is for API, kubelet API, and 10251 is for scheduler, and 10252 is for control manager. And on coming to the compute plane, you see there is 10250, which is a kubelet API. As I already told you, kubelet will be running on the compute plane and control plane. You can see on both the um, tables which it is described. And then we have 30,000 to 32,767. So these are the port numbers which need to be allowed. Why? Because when you come across a topic called service, in the service, it will enable a dynamic port number. So once a dynamic port number is created, that port number will be from the range 30,000 to 32,767. This will be the range which will be used by your service. This has to be allowed before. Why? Because you don't know which port number will be used dynamically. So from 30,000 to 32,767, you have to enable these port numbers. Okay. So these are the port numbers which you have to use beyond the firewall on all the nodes. Okay. Control plane and the compute plane. Okay. So this is all about the introduction related to your Kubernetes setup and the architecture. So let us jump into the practical session, like how to set up a Kubernetes cluster using minikube and kubeadium. For minikube, I'll be using a standalone, which means that I will be setting as a single node cluster Kubernetes using minikube tool, and then I will be using kubeadium to set up one manager and one worker node, one control plane and one compute plane. Let me show you how to do that. Okay, so let's go quickly to that particular point. So here I'm using my local Oracle VirtualBox in order to set up this particular launch, create a VM and set up a Kubernetes cluster on top of this. Okay. So I'm using this Ubuntu 18.04. I have already installed. This VM was created with a basic things like it is having 6 GB of RAM. Let me show you the settings so that you will understand. If you look at this, I'm using Ubuntu operating system. And if you look at the system, it is having a 6 GB, approximately 6 GB of RAM. And then I have allocated 2 VCPUs. I have to allocate 2 VCPUs. Okay. And then after storage and all, it is having a Ubuntu operating system installed. That is fine for me. And the networking part, you can see I have connected to bridge. I'm using a bridge adapter so that my VM is directly connected to a router. How my base machine is connected, my Windows machine is connected to the router. Similarly, my VM wants, I want that to be connected to the router. So in order to do that, I need to use a bridge adapter. Okay, if you want, you can use host only or NAT network and all. Okay, since I prefer this, I'm using this particular option. Sorry, I have didn't saved it. Let me go to the system processor, make it to 2, and then okay. Now let me spin up this VM. So let us log into this. So root, and the password is test123, which I have set, a simple password. So now, if you look at the IP address of this particular node, you can see it is having 192.168.0.50/24. So let me try to connect to this using MobiXterm. So I want to log into this particular VM externally. Session, start new session. So here give the IP address of your VM. So 192.168.0.50. Okay. And the username is root. So the password is test123. Okay. I just logged into this particular machine right now. Okay. So now what I have to do, first thing I have told you that we need to have a proper IP address which has an internet connectivity. So let me verify that by doing a ping to the google.com, and I want to run only 3 ping tests. You can say it is successful. There is no packet loss. Everything seems to be fine. After this, what I have to do, I have to verify my swap memory. Is it enabled or not? So free -h. You can see there is a swap memory enabled and it is having 4 GB of size. So let me try to disable this. So swap off. So without rebooting the system, if you want to disable the swap memory right now for temporary purpose, you have to enable, you have to execute this command. Okay. So this will disable the swap memory. But the problem is if tomorrow when you reboot your system, again the swap memory will be enabled. So I want this to be permanently disabled right now. So vi/etc fs tab. Okay. Come to the last line, you can see a swap memory related entries. Comment out this line, save and come out. Nothing to do. So just save this entries. That's it. Comment out the line and save it and come out. Tomorrow when it is rebooting the system, since every time when your system is getting rebooted, it will try to read the entries in the FS tab, file system tab. Then if it is disabled, obviously the swap memory will get disabled. It will not enable. Okay. So that's it. Temporarily I have disabled right now. In order to make it permanent, I have commented out the swap memory in the FS tab file. So these are the minimum things which I have done. Okay. And then when you have created a Ubuntu VM for the first time, let me show you the version which I'm using so that it will be clear. You can say I'm using Ubuntu 18.04 LTS, long-term service. Means the lifetime of this particular service will be for longer period. Okay. And if you want, you can use 20.04. So that is LTS version as well. Do not use any desktop version because in production servers, you will not see any desktop versions of the service. Always it will be a CLI mode. Okay. You cannot see a desktop version. Always try to install a server edition of any operating system you practice. Okay. If it is CentOS or Red Hat or Ubuntu or a Debian or whatever it is. Okay. Let's, so now we have seen we are using Ubuntu 18.04. After this, whenever you create a VM for the first time, Ubuntu operating system, when it is installed, first command you have to run is nothing but apt update command. Why we need to run this particular command? Because when the VM was created for the first time, means like a new VM was created, it doesn't know what are the repositories it has and whether it is able to means you need to update your apt repository apt database with what are the repositories you have. Okay, so the first time you have to run this particular command so that your apt database will get updated. Once it is done, and you have to run dist upgrade, which means that when the VM is created, the the ISO has older versions of the packages. Now it might have a new versions, upgraded versions of the packages in the current situation right now for that 18.04 version. So you have to upgrade it. Once it is upgraded, in the upgrade process, if you have seen that it is updating the kernel as well, please reboot the system. You have to reboot the system in order to affect the changes. Okay. Right now my kernel version is, you can say this is my kernel version right now, 4.15.0-118-generic. So this is the kernel version which I'm using right now. Okay. So these are the basic verifications which I have done. Okay. Now what I have to do? Now I need to install Docker. Okay. If you want, you can install any other container runtime interface. But I prefer right now to install Docker, and then I will be setting up the Kubernetes cluster using minikube tool. Okay. So let me show you the documentation of it. So this is the official recommended documentation. So first what I need to do, first I need to download the minikube package and I need to give the execute permissions. After that, I need to move it to the proper binary location. Okay. So let me try to do one after the other. Let me copy this and paste it here. So execute. So now it is downloading the minikube binary and then it will give the execute permissions. Once that is done, I have to move this particular, so this directory will be there. No need to create from your end. So this directory will be there. Just you need to move that particular minikube to that particular binary location. Okay. So let me try to do that. Yeah. So now you can see ls minus lrt. So you can see there is a minikube. Okay. So it is having a execute permissions. Now let us try to move this particular minikube to a binary location called /user local bin. Okay, once it is done, you will be able to execute minikube as a command. Okay, -f help. You can see it is executing as a command. Now we are good to go and install set up the Kubernetes cluster using minikube. So in this part, you have to understand it supports a lot of drivers, but since you are trying to set up on the same machine where you have already installed a minikube client, so there is no need to specify a driver. So let me show you the command what need to be used in order to set up the Kubernetes cluster on the same node. So minikube. Okay, after that start, and then if you want more options over here, just you need to give -f and help. It will show you the lot of options that need to be used. Okay. So among this, I want to set up the Kubernetes cluster over here using minikube. So simple, same command. Just here we need to use an option called -f driver is equal to none. Okay. And then what Kubernetes version you want to use? Let's say -f Kubernetes -version. Let's say I want to set up 1.18.04. So the latest version is 1.19.3, but I want to install 1.18.4 or 1.18.6 is the last in 1.18 series. In 1.18 series, 1.18.6 is the last version. After that, they have released 1.19.0, 1.19.1, 1.9.2 and 3. Okay. So let me try to install 1.18.6. Let's go with that. Okay. Now enter. So you can see here, it is telling you that Docker executable file not found. As I told you, so this is a suggestion. Just I want to show you the error. What will happen if you don't install any container runtime interface? Now you can see exited due to the provider none not found. None provider was not found, which means that Docker itself is not installed. So that's the reason it is failed. So what you have to do first you need to install Docker. Without doing that, you cannot go and install Kubernetes. Okay. So for that only I have made it to fail. So since it is Ubuntu, let's follow the documentation. So always it is better to run this command. Why? Because if unfortunately an older version of Docker is installed, so it will create a mess up. So I don't want to use that. So let's try to see if there is an older version. Now you can see there is no older version of packages available. So we are good to go and install the latest version. So scroll down, and you can see update command. We have already ran it, so no need to run once again. So here we are trying to install the minimum packages needed. Okay, in order to proceed further. So enter. So it is trying to install minimum packages. It is done. After that, we need to download the ZPZ key. Since you are using an open source Docker version, so you have to download the ZPZ key. Okay, done. If you want to verify whether this particular GPZ key is there or not, apt-key list. Okay, you can see here. Okay, so this is how you can verify it. After that, so ZPZ key got installed. So here also they are trying to do the same thing, but I've shown you a simple command instead of this particular command. After that, you have to create a repository. So in order to install the Docker package, we have to download the package from the Docker official repository itself, not from the Ubuntu repository. So that's the reason we have to create this particular Docker repository. What it will do, this command will add an entry in the repository file. What is a repository file? If you already have some knowledge on the Ubuntu. So apt, sorry, it's a cap lock. Source.list is one file. If you want to create a separate file, it will be created under list.d. Okay, always remember the extension of the files which are placed under source.list.d should be .list, the extension that is mandatory. So please follow that particular thumb rule. And if you see, now our entries are added into the main file itself. Okay, so let's copy this. If you go to the bottom, you can see Ubuntu related, sorry, Docker related entries have been added. Okay, so we are good to go. Once a repository has been added, whenever you modify this particular file or entries have been added, if you see the file, that's okay. But if you have modified this particular file or the files under that particular directory, always you need to run apt update command for Ubuntu operating systems. Okay. Once that is so, why we are running this? You are updating the apt database saying that there is a new repository added. Okay. So it will try to communicate that and it will tell you whether it is reachable or not. Okay. So that's a one thing you have to remember always. Then let's try to install the package. So there are three packages which are divided as per Docker community. So what are those packages? One is, this is related to daemon. In Docker, we have client and daemon. So daemon will come from this particular package. Client will come from this particular package, and containerd-o is a backend runtime interface which is used by Docker. See, Docker itself is not creating a container actually. Docker is using lot of other technologies which are provided by Linux and other tools, and then it is creating a wrapper by clubbing all those particular tools, functionalities. Okay, so that's how it is. So that's the reason we are installing these three packages in order to have the Docker installed with all the required resources. Once this is done, then we are good to go and install a Kubernetes cluster using minikube. It will take hardly 2 more minutes. It all depends upon the internet speed as well. Hope it is done almost. So once this is done, so let's verify with the Docker version. Okay, hyphen version, just to verify it. Okay, you can say it is 19.03.13. So that is the latest version of the Docker which we are using. Now the Docker which we have installed is a community edition, not an enterprise edition. It's a community edition in the sense it's a open source. Okay, that's the reason we have downloaded a ZPZ key, the public key actually it is. Okay, so after this we have to run the minikube command. So what's the command we have executed earlier? Let's try to recap it. So this is the command we have executed, right? If I'm not wrong. So when this got executed, it was failed saying that there is no runtime interface to spin up the Kubernetes cluster. Now we can see we got another issue saying that Kubernetes requires a contract to be installed in the roots path. So this is one of the package which we have to install. See, why I am not doing this before is because I want to show you what are the errors you will face when you don't have the minimum required things. Okay, that's the reason. If not, I would have installed this first and I would have shown this working as a perfect. Okay, but I don't want to do that. Okay, so here, if you see it, when it is trying to install 1.18.6, it requires a contract to be installed in the root path. What does it mean? It's a package actually. So let's try to install apt install. And now we can go ahead. So look at the documentation. They will tell you the same thing. Okay, move to the binary location, updates. You can, if you want to use a separate driver, you have to mention that. Once it is installed, we have to use minikube status in order to see what got installed. Okay, if you want to stop it, you can use minikube stop. If you want to start up the cleanup, so minikube delete and all, it will try to remove everything. Okay, so running Kubernetes locally via minikube. Okay, so this is the documentation, official documentation. Once this is done, we have to install another package that is called as kubectl. That is a binary, that is a package which need to be installed if it is not there. So now we can see the Kubernetes setup has been done. So you have to, if you look at the output, they are telling you that kubectl and minikube configure will be stored in root directory. And to use kubectl or minikube commands as a own user, you have to run the following command. So you have to execute this command, execute this particular command, and then, okay, so this is already there. You are on the same directory, so that's fine. And the ownership we have to change. It is already root. I think it's not needed for us to change. Okay, so which means that if you look at this particular directory, you have this particular files and directories. Okay, so it is a simple thing. So, and one more point is nothing but you will have one more directory called .cube. Under that, you will have a config file that is so important for us to authenticate to the Kubernetes cluster. Okay, now let's try to kubectl. So we have to install one more package which is called as kubectl package. So that is a client package which need to be installed in order to interact with the Kubernetes. See, Kubernetes setup was done, but for you to interact with the Kubernetes cluster, we have to install kubectl command. Okay, so let us try to do that. So in order to install that, say this is the document which I'm using in order to install. So just copy this. And instead of 1.19, I'll just try to use 1.18.6, whatever the version I'm using. Okay. So once it is downloaded, we need to give execute permissions and we have to move that into the binary location. Generally, whatever we do, the same thing. Okay. I hope it is downloaded successfully. Yes. So you see there is no execute permissions. So let's try to give the execute permissions. Chmod is a command and plus X in the sense for everyone you are giving execute permissions. And now if you see, you got the execute permissions. Now let's try to move this kubectl package to user local bin and the directory, right? Now you can execute the kubectl commands. You can see now the kubectl is executed as a binary. Now, in order to interact to the Kubernetes setup, which was done through minikube, generally we execute kubectl get nodes. Okay, you can see there is a master node which was installed and it is ready state. And you can see the Kubernetes version which you are using is 1.18.6. Okay, if you want to see the Kubernetes releases and all, if you click on the version of the official document, you have 1.19 is the latest version and we are using 1.18. Okay, if you want, you can install 1.19 as well. No issues with that. Okay, so right now I have shown only 1.18. So it's up to you. If you want, you can use that as well. Okay, no issues with that. So this is all about Kubernetes setup using minikube tool. There is one more tool called kubeadm where you can use in order to set up the Kubernetes cluster. So let us watch that in the next video. Okay, thank you.